We have 6 points plotted on this scatter graph, and we're asked to plot the other 4. So marks in January is along the x-axis, and marks in February is along the y-axis, which means I can go to do the next one. I can go along to 70 and then up to 86 here, and then along 44 and up to 60, 37 and 48, 38 and 50. What type of correlation is it? Well, as they do better in January, they tend to do better in February. We've got this sort of general trend of a positive gradient, and it's known as positive correlation, as opposed to negative correlation if it was going this way, or no correlation if it was like all over the place. Circle the student who's made the greatest improvement from January to February. Well, if we just sort of go down this way, we can see they're kind of doing, well, they've improved, haven't they, a little bit, but where's the greatest improvement? Here's quite significant improvement from 26 to 42, but that's not as big as this improvement here. It's gone from 30 to 66. That's an improvement of 36, and that is going to be the one with the greatest improvement. Percentage change in the students' marks from January to February. So they did get 30, and now they've got 66. So new equals old times multiplier. This is a formula I like to use. Then I can get my multiplier, and I can get the percentage change from that. There's a common factor of 3, so it's going to become 22 over 10. Therefore, 220 over 100, which is actually 220%, and therefore the increase is 120%. If you're not a fan of that, then you can actually learn this formula, that percentage change equals change over original, or the old value, times by 100. In this case, the change would be 36. You'd get 36 over 30 times 100. You still have to do quite a bit of work. 12 over 10 times 100, and that would get you 120% as well. Another student scores 79 in the test in January. So up here, it was absent. Kai says I could use a line of best fit to estimate it. Is the method reliable? Well, because we're here, we're actually outside the data range, and therefore it's not considered reliable. No, because Kai's mark is outside the data range. Technically, this is known as extrapolation, and it's not considered reliable.